Good day everyone, I'm Jessica Resari Pumay from BSed Pinupino 1B. And we are the week 13, so we assigned to tackle about the nano world. So as we are to begin, these are the learning objectives. The student should be able to: first, define nanotechnology; the second, characterize nanoscale; the third, describe the various uses of nanotechnology; the fourth, discuss concern on the use of nanotechnology; and the fifth, explain the status of the use of nanotechnology in the Philippines. So let us come now to introduction. Scientists researchers have developed new technological tools that greatly improve different aspects of our lives. The use of nanoscale is one important interdisciplinary area generated by advancement in science and technology. Scientists and engineers were able to build materials with innovative properties as they manipulate nanomaterials. Indeed, research and application of knowledge on nanomaterials will continue to bring widespread implication in various areas of the society, especially healthcare, environment, energy, food, water, and agriculture. And so let us come now to meaning of nanotechnology. Nanotechnology refers to the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanoscience and nanotechnology employs the study and application of exceptionally small things in other areas of science, including material science, engineering, physics, biology, and chemistry. The concept of nanotechnology in nanoscience started in December 29, 1959, when physicist Richard Feynman discussed a method in which scientists can direct and control individual atoms and molecules. In his talk, "There's Plenty of Room at the Bottom," during the American Physical Society meeting at the California Institute of Technology, the term nanotechnology was coined by Professor Norio Taniguchi a decade after the dawn of the use of ultra-precision machining of 2017. Okay, so let's move on to how to view nanomaterials. Scientists use special types of microscope to view minute nanomaterials. During the early 1930s, scientists used electron microscopes and field microscope to look at the nanoscale. The scanning tunneling microscope and atomic force microscope are just among the modern and remarkable advancements in microscopy. So, how small is nanoscale? A nanometer is a billionth of a meter. The illustration below shows how small nanoscale compared to other particles or material. Manipulation of nanomaterials needs an adept understanding of their types and dimensions. The various types of nanomaterials are classified according to their individual shape and sizes. They may be particle tubes, wires, films, flakes, or shells that have one or more nanometer-sized dimension. One should be able to view and manipulate them so that we can take advantage of their exceptional characteristics. So let us come now to the electron microscope. German engineers Ernst Ruska and Max Knoll built the first electron microscope during the 1930s. This type of microscope utilizes a particle beam of electron to light up a specimen and develop a well-magnified image. Electron microscope produce higher and better resolution than other light microscope because they can magnify object up to 1,000,000 times, while conventional light microscopes can magnify objects up to 1,500 times only. Scanning electrons microscope or SEM and transmission electron microscope or TEM are the two general types of electron microscopes. Number 2, atomic force microscope or AFM. It was first developed by Gerd Binig, Calvin Quate, and Christoph Gerber in 1986. It makes use of a mechanical probe that gathers information from the surface of a material. And then number 3, scanning tunneling microscope. This special type of microscope enables scientists to view and manipulate nanoscale particles, atoms, and small molecules. In 1986, Gerd Binig and Heinrich Rurer won the Nobel Prize in Physics because of this invention. Okay, so let us come now to the nanomanufacturing. It refers to scaled-up, reliable, and cost-effective nanomanufacturing of nanoscale materials, structured devices, and systems. It also involved research, improvement, and incorporation of processes for the construction of materials. Therefore, nanomanufacturing leads to the development of new products and improved materials. There are two fundamental approaches to nanomanufacturing, either bottom-up or top-down. So let us come now the two fundamental approaches to nanomanufacturing. First, bottom-up fabrication. It manufactures product by building them from atomic and molecular scale components. However, the method can be time-consuming. Scientists and engineers are still in search for effective ways of putting up together molecular components that self-assemble and from the bottom up to organize structures. And the second, top-down fabrication. It trims down large pieces of materials into nanoscale. This process needs larger amount of materials and discard excess raw materials. There are new approaches to the assembly of nanomaterials based from the application of the principle in top-down and bottom-up fabrication. This includes deep pin lithography. It is a method in which the tip of an atomic force microscope is dipped into a chemical fluid and then utilized to write on a surface. The second, self-assembly. It depicts an approach wherein a set of components join together to mold and organize structures in the absence of an outside direction. And the third, chemical vapor deposition. It is a procedure wherein chemicals act in response to from very pure high-performance films. And the fourth, nanoimprint lithography. It is a method of generating nanoscale attributes by stamping or printing them into surface. And the fifth, molecular beam epitaxy. It is one manner for depositing extremely controlled thin films. And the sixth, roll-to-roll processing. It is a high-volume practice for constructing nanoscale devices on roll of ultra-thin plastic or metal. And the last, atomic layer epitaxy. It is a mean for laying down one atom thick layers on a surface. With the use of these techniques, nanomaterials are made more durable, stronger, lighter, water-repellent, ultraviolet or infrared, resistant, scratch resistance, electrically conductive, anti-reflective, anti-fog, antimicrobial, self-cleaning, among others. The above-mentioned nanotechnology-enabled products such as tennis, rackets, and baseball bats to catalyst for purifying crude oil and ultra-sensitive recognition and classification of biological and chemical toxins. So, it is not impossible that in the near future, computers that are better, more efficient, with larger storage of memory, faster and energy saving will be developed soon. The entire memory of a computer will be saved in a single tiny chip. Moreover, nanotechnology has the potential to construct high-efficiency, low-cost batteries and solar cells. And so let us come now the product of nanomanufacturing of 16-gauge wire. Approximately 1.3 millimeters in diameter, made from carbon nanotubes that were spun into thread and the same wire on a 150 ply spool. Source Nanocamp. So that would be all. So I hope to watch this video till end to explore what nanotechnology is and the broad aspect of it.